Okay, this is P.9. There are some specific directions here for the assignment. Try to make sure you pay attention to that. 2 through 26 is every other even, so that would be 2, 6, 10, 14, and so on. 30 through 38 and 50 through 56 are all the evens. For 18, 22, and 26, you must follow the book directions when showing your work. That means that you're using graphs to find each set. There are a couple ways to talk about a collection of numbers. Okay, so for example, if I wanted to talk about all the ages of the people at Park Center on a daily basis, we might have some 15-year-olds, that might be the youngest, and then maybe some people who are close to retirement age, which is 62. So I'll put that there as the highest age. And then all the other ages would be somewhere in between 15 and 62. So I'll shade in all those numbers in between. I didn't write them in, but I'm just shading them in. And if I want to include 15, I put a little bracket here. You might have used to do this as a solid circle, but in higher level math we use a bracket. Up here again we use a bracket instead of the solid circle. Alright, now that's what the graph looks like, all the ages between 15 and 62 including the ends and values. Okay. There are two different ways to write this collection of numbers. One is called interval notation, where we write the number on the small end, comma, number on the big end, and then either parentheses or brackets. A parenthesis would not include an age, but a bracket does include the age. So that's interval notation. Set builder notation is the other way to talk about all the numbers in the set. And that would be all x's such that 15 is less than or equal to x, which is less than or equal to 62. And you put curly brackets on each side, and there you go. We're going to be focusing on interval notation today. So, example 1. They want us to translate that from interval notation to set builder notation and then graph it. Well, okay. If I were talking about I like to make the graph first of all. So if I were talking about these two numbers, -2 is on the smallest end, and then 5 is on the high end. And we would include -2, would we not include 5? Hence the parenthesis. And then we would shade everything in between. That's what this means. So if I want to talk about writing this in interval notation, or in set builder notation, I would say this is x, all the x's such that -2 is less than or equal to x, which is less than 5. Notice here we have less than or equal to because -2 is included. Here we don't have equal to because 5 is not included. And brackets like so. Here's another one, between 1 and 3.5. Here's the number 1. Here's 3.5. We're going to include 1 because the bracket's here. Include 3.5 because the bracket's there. And we're going to shade in everything in between. So, set builder notation would be all x such that x is less than or equal to, 1 is less than or equal to x, which is less than or equal to 3.5. One is less than or equal to x is less than or equal to 3.5. Again, notice I used or equal to on both of those, simply because they're included here. These brackets mean that those endpoints are part of the set of numbers we're talking about. And our curly brackets, and there you go. Now, sometimes you don't get just kind of numbers in between a set of numbers in between two other numbers, sometimes numbers go to infinity. So if we're talking about negative infinity as being the smallest set of numbers and negative 1 as being the top, negative infinity basically would be all the way going towards the left. Now obviously we can't shade to the left forever, but we can shade in the arrow. And then all the numbers up until negative 1. Negative 1 is not included, so that'd be parenthesis. Now, basically we're talking about all the numbers that are less than negative 1. So set builder notation would simply say x such that you have all x's less than negative 1. And here, the smallest number is 6 and the biggest number is positive infinity. So 6 would be here, it is included, and then all the way up to positive infinity. So again, this is the left number, the lowest number, and the right number is the highest number. So I'd shade all those in, and that's my graph. And then all x such that x is greater than or equal to 6 would be my set builder notation for that set of numbers. Okay. Now, we talked about this symbol on the first day of our lessons this year. This means intersection. It means what is shared or what overlaps. I like to think of it as the second definition, the overlapping parts. Because what we're going to do right now is I'm going to graph each one of these. Okay, I have 1, 2, 3, 4, 5, 6. I'm going to make 2 more just like that. 1, 2, 3, 4, 5, 6. Try to get it all lined up exactly in the same way. Okay. Between 1 and 3 would be here, including the endpoints. So this is the graph of this. Now I'm going to graph that between 2 and 6, but not including the endpoints. All right. So the question now is, what is both shaded in here and here? Well, 1 is not. The shading between here and here is not. 2 is not because it's not included there, but this section right here certainly is. So I can shade in this section. Is 3 included on both sets? Yes. Here it's included and here it's shaded. And then everything up here we don't have here. So really the only overlapping section we have is here between 2 and 3, and then also the value 3. We don't want to include 2 because 2 is not shared on both because it's not included in the second set. So we would use a not included answer. So that is how I determine what is overlapping. And my final answer therefore is between 2 and 3, not including 2, but yes including 3. That's my final answer. Notice how I solved this by graphing. That is the simplest, easiest, most error-proof method of finding intersections of these types of sets.